Hello, this is Gareth from Creative Conners. Today we're going to configure motor scaling and motor forward and reverse position limits. I've opened up Spikemark. I've got a single motor here. It is connected over Ethernet. And what I want to do first is set the scaling factor. Scaling factor can be found in the position box inside the motor editing pane. You can see here, this is position scale and position units. Position scale allows the computer to show us position information in units that make more sense than raw encoder counts. This is actually a pretty simple operation. All we do is run out the motor to a specific point in space, measure how far it traveled, see how many encoder counts were used up to travel that far, and then do some simple arithmetic to come up with a scaling factor. So I'm going to scroll down until I find my manual controls. I'm going to run it in the forward position. And now I'm just going to run it for a little ways. And that's probably fine. Now, physically with a tape measure, I'm going to measure how far we traveled. And I came up with 101 inches and a half inch. So I go to my calculator and I'm going to select the standard view to get a simpler interface. We want counts per inch, so we punch in the counts we traveled, which are a large number, 1,954,997 divided by 101.5 inches. And now that roughly gives us a scaling factor of 19,261. So I scroll back up here and enter that into my position scale. I'll go ahead and just copy and paste this number. And I've pasted the number in. Now, as soon as I tab out of this field, you can see the position has changed to 100.5. It still says CTS for counts. I want this to be in inches, so I'm going to select inches from the position unit menu item. There we go. 101.5, we now have the unit inch mark. And we can see that our wagon is now back on stage. It had previously shot way off into outer space there when we were up at 1,000,000 counts. But now it's back at a reasonable position. Now that we have our scaling factor figured out, the next order of business is to determine the forward and reverse position limits. These are labeled max forward position and min reverse position. These values won't actually stop the motor from physically traveling beyond these numbers, but what it does allow us to do is to keep the operator from entering in values that are way off base. Basically, it protects you against entering a typo so that you don't try to send the motor through a wall or through the basement. To determine what the maximum position is, I'm going to jog this forward until I feel like it has reached as far as I want it to travel. Typically, you're going to set these software limits to be a little bit inside of your actual hardware limits. Okay, that seems reasonable. So my position here is 221.68. I'm going to round that up, and we'll do that to 221.75, so 221 3/4 of an inch. My minimum reverse position, we can leave it at 0, or you can set it to either a positive or negative number. If you want to, say, leave your reverse physical limit at actual 0, maybe you want to cheat your software limit to 1, and maybe let's call it 1.5 just for argument's sake here. Great, so now we've set forward and reverse software limits. And what has happened here on screen, you can see, is that Spikemark has stretched the diagram of the track to accommodate the full length of travel. Spin this around so you can see. We have a green arrow here, that represents the forward physical limit switch, green meaning clear, red would be the limit's engaged, gray would mean that the motor is not connected, and then you've got a little ball at the other end of the track. That's your reverse limit, which is also currently green. The wagon itself is represented with this white rectangle, and the orange cage around it just tells us that this is the motor that has been selected and we're currently working with it. This is Gareth from Creative Conners. In today's short movie, we're going to look at running cues in Spikemark. To run a cue in Spikemark, the first thing you need to do is load it. There are a few ways to load cues. One of the easiest is to press the Load Cue button in the cue grid. The cue is loaded. We see where the motors are going to be running to, and now we can execute this cue by pressing the Run button on the cue controller. As you can see, status information for the cue is updated in both the status bar and in the cue controller window. As motors complete moving, their outlines turn from green to blue, indicating that they're now complete. Once all motors are complete in the cue outline in the cue grid turns blue. To load the next cue, we can press the Next Cue button. This will load the next cue in the show sequence. To run it, I could press the Run Cue button again here, or press the Run Cue button on my showstopper base station. But instead, I'm going to select Run Cue from the menu. As you can see, Run Cue from the menu also has an F key equivalent. This makes it easy to run a show without a showstopper base station nearby, but using the F keys on your keyboard so you don't have to use your mouse. While this cue is running, I'm going to load up cue 3 and execute it. This is known as pile-on queuing. I can run multiple cues at the same time just by loading them and executing them. This is great in shows where you have a sequence of cues that need to run at the same time, but perhaps from night to night the sequence differs. For instance, if it's actor-driven, or perhaps the stage manager has to call the cue. You can't write an automated link in that instance, but you still want them to be able to execute in a staggered fashion. Alright, let's now load up cue 5. I want to skip over cue 4. Let's say I'm in the tech rehearsal process, and cue 4 doesn't need to be run. To jump to that cue, I could just as easily press the Load Cue button on the cue grid, or press the Jump to Cue button here on the cue controller. This brings up a list of all the cues in the show and allows me to select which cue I'd like to run. I select cue 5 and press OK. Cue 5 and cue 6 are linked together by time, and as you can see, cue 6 executed 2 seconds after cue 5 had started. Now if I wanted to, I could pile on cue 7 and run it. Let's say I needed to stop cue 7 at this point. I can press the Stop Cue button, and that slowly decelerates the cue to a stop. It takes the programmed acceleration rate, which we can see here as 10 inches per second, and applies that deceleration rate immediately. This works whether I'm running one cue or maybe even multiple cues. Here I've got 2 cues running. I can press the Stop button and both motors stop. All 3 cues now show a fault status as indicated by the yellow outline. The fault status is displayed anytime you stop the motors with an emergency stop or with the soft stop on screen. Another reason why you might see a fault status would be a limit switch being engaged, or perhaps a position error fault. The fault status will clear as soon as the motors are loaded in another cue. The turntable has now been loaded in cue 6, and its fault status from cue 8 goes away. That wraps up our look at running cues in Spikemark. As you can see, Spikemark makes running cues a pretty easy endeavor.